Okay, this is Lecture 5, Part B. We've been looking at structured programming. The notion of structured programming is a way to write your programs and guarantee they work every time. And what we want to look at is structured programming in the context of assembly language. So later we'll also be getting into bit masking in this also. So structured programming is the idea that you can decompose any well-written program into these three structures. And if you can't, your program is spaghetti code. It probably won't work 100% of the time. It's hard to maintain. You can't really use it. Hard to understand. So the three programming constructs are sequence construct, if then else, and iterative. So if then else, you've heard of case statements. So it's actually a special case of an if then else construct. Also, iterative constructs, which are just loops. We know that there's two types of loops, which is a while loop and a do-while loop. Difference between these loops is a do-while loop, it's guaranteed to execute the body of the loop one time, while a while loop, it may never execute the body of the loop. So with a while loop, you're going to check the condition before you execute the loop, not with a do-while loop. Okay, so with the point being in this is these two issues right here, is the if-then-else and the iterative construct are made up of have branch statements in them. The branch and conditional and unconditional branches is what makes them work. So let's look at it. Okay, so this is a if-then-else construct. Here's a nice little flowchart there, and here's my little decision box. So if it says if x20 equals 0, which means if the value at x20 is equal to 0, it does this subtract operation. Otherwise, or else, it does this add operation. And then when it's done, it comes together at the end here. So essentially, this is the code, kind of C-looking code. I know C doesn't have thens in it, but close enough. So here it is. If x equals 20, do this operation. It was just subtract. So the way we're going to implement this is with a conditional loop right here, which is this BEQ, which is branch if equals. So if the value in x20 equals the value in x0, the value in x0 is always 0. If those two values are equal, it jumps to the instruction associated with that if label. So the if label is arbitrary. I just used that to make it look like an if then else statement. And so essentially if x20 is equal to 0, it jumps down here and does this. Okay, and so this is a subtract instruction. You wouldn't know exactly how this works unless someone tells you. It's going to take the value in x18, subtract the value in x19, store the result in x17. So x18 and x19 are source registers. The destination register is x17. So if it doesn't take that jump, the condition fails, and it's going to drop through to this instruction, which is essentially the else. The else is an add instruction. It adds these two source values, stores the result in x27, which matches this. But after I do that, I in the code, I have to jump over the if. I don't want to execute that if statement if I've executed the else, so I have to put that physical unconditional jump over the if. Okay, so that's it. Now the thing to take away from this is this if then else construct. I have a conditional branch in there, and I have an unconditional branch. The BEQ is the conditional, the J is the unconditional. Typical structure here. Now there's a couple ways to do this. Actually, I'm going to slow down because I'll never fit this in this lecture. There's a couple ways to do this. I could structure this differently. I think there's some examples in the book where you can structure it differently. Essentially, you can, switch the if and the else in here and use a different instruction on this thing. All the same thing. It's functionally equivalent code. So lastly here, a couple things here. This is actually an instruction. It's a pseudo instruction, which the no-op stands for no operation. I don't really do anything. I just wanted to put an instruction there. The label that's used in this is the if label, but I actually included 2 more labels as in, I've kind of used them as comments. They're not really comments, but I can plop them in the code, and it does not make the code any longer, but it does make the code more readable for humans. So by all means, you should use labels freely and openly. So this is an iterative construct. This happens to be a do-while loop. It's kind of a chunky piece of code. The issue is in this do-while loop is it looks something like this. I'm doing something and then I'm checking the condition. So this add here is essentially the bottom, is essentially the body of the loop. And by the way the code is structured, I am going to do at least one add on this thing. So the code itself is kind of, like I said, it's kind of like stupid code that it gives you an idea of what's going on here. So generally speaking here, what I'm doing is I'm initializing some register to be an accumulator. This is the body of the loop. I'm just adding some value to it, and then I have to check the condition. Okay, so here I am using this load immediate instruction right here. The load immediate instruction takes the value of 923 as a decimal and sticks it in that register. Next instruction here is a move instruction. We've seen these before. Essentially, it's going to take the value in x0 and put that value in x20. So the value in x0 is always 0, and I'm going to essentially clearing the x20 register. I'm putting 0 into the x20 register. For this problem here, I'm using x20 as an accumulator, so I'm starting it at 0. So here's the body of the loop here. This is just some random add statement, and so I am adding, as this is I'm using x20 as an accumulator, so I'm taking the value in x20, adding the value of x23 to it, and then I am storing that value in x20. Now the piece of code here never really stated what was in x23. I have no idea what's in it, so we're just pretending like there's a value in it. So after I do that accumulate operation with the add, which is essentially the body of the loop, I am going to check the condition. And so this condition here is, this is a branch instruction, conditional branch instruction. It says branch if less than. So if x20 is less than x22, it branches to the instruction associated with loop, which is this add instruction. So it does the add instruction once again. So eventually what the thought in this piece of code here is that I'm going to keep executing these 2 instructions till eventually the value in x20 becomes essentially it becomes greater than the value in x22, which means this condition fails, which means it drops down through to the next instruction. So once again, this is a notion of a loop where I don't really know how many times I'm going to do it. So here's another type of construct. This is actually a while loop. The previous example, previous fragment was a do while, but this is another iterative construct. Once again, because it's a while loop, I'm going to check the condition before I actually enter the loop. So this is a typical loop. I know how many times I'm going to be in this loop, because the first thing I do here is I'll put a value of 10 into register x20. So x20, it doesn't really matter which register I use, but I'm using x20 as a loop count or a loop variable or an iteration count. Many ways to say this thing. So that's where I'm initializing the thing. Then I'm checking the condition. I'm actually, when I'm doing these, I have to decrement the loop variable and then check to see if I have to do it again. So let's look closely at this thing. As what I'm going to do here is continue in this loop until x20 equals x0. At that time, I'm going to jump out of the loop, because when x20 equals x0, I started x20 at 10. I'm going to decrement it every time through the loop eventually I'm going to just essentially jump down to this instruction here. So the first time through, the value in x20 is 10. It's not equal to 0, so it doesn't jump. It drops down to this instruction, which is some chunky add instruction, no big deal, but this is the important one. This is the body of the loop. This is kind of the loop administration. I typically use that word a lot. Essentially, I'm decrementing the loop count. So this is a decrement operation. I'm taking the value in x20. I am adding a -1 to it and storing that value in x20. So that's a decrement. And once I do that operation, I'm jumping back to the instruction associated with a loop, which is in the instruction that checks the condition once again. So essentially, it's this instruction here. I'm jumping back and checking the condition again. So it's the jump. Doesn't really have a box for it. It's more of a directional thing. And I think that's it for that. I'm going to break this here and break this into 2 lectures. So